we're going to start by investigating graphs and their inverses. So the first question asks us to list 3 points that lie on the function f of x, which is 2x plus 1. So I'm going to find 3 of those points, one at 0, 1, 1 point at 1, 3, and then I'll do another point down in the negatives at -2, -3. Then it says that knowing that the inverse, which is this symbol, is a reflection across y equals x, what are the 3 corresponding points for f inverse? So if we go and look at the point 0, 1, the corresponding point here would be at 1, 0. Then we can look at the point 1, 3, and the corresponding point for that one would be over here at 3, 1. Finally, we have the point -2, -3, and that corresponding point would be over here at -3, -2. So what do we notice about the corresponding points, the coordinates of those corresponding points? We notice that the x's and the y's are just switched. So we can conclude that to find the inverse of a relation of ordered pairs, we simply swap x and y. Let's put this into practice with a relation. I have a relation at 0, 3, 4, 2, and 5, -6. The inverse of 0, 3 will swap our x and y, becomes 3, 0. The inverse of 4, 2 is just 2, 4. And then the inverse of 5, -6 is just -6, 5. Those are now inverses. What if we were given a graph? Could we determine whether the 2 lines are inverses of each other? Number 3, to start that off, we need to first draw that line of reflection. Remember, the line of reflection happens at y equals x, which means they have points at 0, 0, 1, 1, 2, 2, and so on. This happens to be a square graph, so that means that y equals x will be the diagonal of that graph. If it was a rectangular graph, that's not always going to be the case. That's why it's important that you pay attention that it goes through the points 0, 0, 1, 1, 2, 2. Make sure that we label it as y equals x. And then to determine whether they're inverses of each other, we're going to use that same principle of swapping x and y. So I'll first find the value of 3 to 4 points on the original or on one of the lines. So I'll use this line, and I'm going to find 3 to 4 points here that are on directly that line. So first one I'm going to find is at 3, 4. Then there's another one at 2, 3. Another one at 1, 2. And if we find the inverses of those 3 points, we would have 4, 3, 3, and if we were to find the inverses of those 3 points, we would have 4, 3, 3, 2, and 2, 1. Let's verify that those are going to be on the other line. 4, 3, 3, 2, and 2, 1. All 3 of those points ended up on the other line, so they must be reflections of each other. So we'll simply say, yes, they are inverses. because the lines are reflected across y equals x. Let's take a look at the next one. We'll first draw in our y equals x line, going through 1, 1, 2, 2, 3, 3, and so on. Again, it happens to be a square. That's why it goes through the diagonal. They will not always be squares. And if we just look at a quick glance, it does look like they are reflected, but we do have to show that. So we're going to identify 3 to 4 points. So I'll use 1 point over at -5, +3. And then another point at 0, 2. And we'll use one more point over at 5, 1. And if we find the inverse of each of those points, we'll have 3, -5, 2, 0, and 1, 5. And plotting those points, 3, -5 on the line, 2, 0 on the line, and 5, 1, 5 also on the line. Yes, they are inverses because the lines are reflected across y equals x. What if they didn't give me both lines? Could we find the inverse and graph it? So again, we're going to start by finding that reflection line going through y equals x. This happens to be a square graph, so it goes right through the diagonal. And we know that they're going to be reflected across that line. So we are going to identify as many points as we can. On the test, I would ask that you identify 4 or more points. So we will start with finding the first point at 2, 6. Second point at 0, 3. And our third point will happen at -2, 0. Again, we could continue to find more than that. There's even one at -4, -3. But we don't want to use the point that lies directly on y equals x. And the reason for that is because when I find the inverse of it, it's not going to help me find the line. So we want to stay off of the reflection line. Then we can find the inverse of each of these. 6, 2, 3, 0, 0, -2, -3, -4, and then plot those lines on the graph. Once those are plotted, you connect your dots. And there's our inverse. Let's do the next one. First, we'll find points on the original line and we'll graph our y equals x reflection line. On the original line, we have just 2 points that cross at nice intersections, one at 0, 4 and one at 1, -2. So when we find the inverse of those, we'll have 4, 0 and -2, 1. Plotting those points, 4, 0, -2, 1, and connect those dots. They do look like they are a reflection. You can check that off your reflection line by saying it went 1, 2, 3, 4 to the right, so then it would have to go 4 down. 1, 2, 3, 4, perfect. And this one went 1, 2, 3 to the left, so 3 up, perfect. on the test, they're going to be more of a curve line. So we'll draw our reflection line. For y equals x, and then we'll find as many points as we can. I would say the test you're going to want to do a minimum of 4 points to make sure that you get a really good line. We'll start off with the point at -9, -8. Then we have -5 and 3. 1 at 7 and -2. 1 at 8 and 1. And then back at 7 and 9. And then we can find the inverse of each of those by switching x and y. Now, I do recommend that you write down your points in order of how the line moves, not just in order of how it goes left to right. And then when you're plotting your points, I recommend you do the same thing. Plot them in order of how they move or how you found them, not just from left to right or smallest to biggest or biggest to smallest. So we're going to go to -8 and then down to -9. Then we're going to go to 3 and down to -5, -2 and up to 7, 1 up to 8, and finally 9 to 7. And then you're going to connect your dots in the order that you plotted them. So that went from here over to here. And you can see that it looks like a reflection, so we've done okay. For our next one, we need to plot our reflection line. Happens to be a square graph, so I can take advantage of that and just do the diagonal. And then we're going to plot our points. First point plotted is going to be at -9 and 6, -5, -6, -1 and 2, and then 9 and -6. Then the inverse of each of those by swapping x and y. We want to plot those in the order that we wrote them, which follows along the line. So we'll go to 6, -9 first, then -6, -5, 2, -1, -6, 9. We're going to connect those in the order that we plotted them. So starting with 6, -9. And again, double check that it looks like it's been reflected, and we're good.